looking at quantitative data. Quantitative data, there are many different graphs that we like to look at. Dot plots, and dot plots is good when we have a small data range. Stem plots, histograms. Histograms are very good for very large data sets. We have box plots. And we have something called a time plot and an ogive. This lesson, quantitative data, we'll call this quantitative data lesson number 1, deals with dot plots and stem plots. Okay. Dot plots. If you are looking on your sheet, we are on Roman numeral number 4, A. Okay, and they give you a bunch of data. 36.3, 32.7, 40.5, 36.2, 38.5, etc., all the way to 39.5 and 36.9. Now, if I am going to make a dot plot on this, it's kind of difficult to do it with decimals. Okay? Dot plot does better for whole values. Now you can do decimals if you don't have that much of a decimal range. If you only have like a range of like 10 for the decimal, going from like 36 to 37. This is going from the smallest is around 32 and the highest is around 41. So if we're going from about 32 to 41, you don't want to use those decimals here, at least for a dot plot. Now if you did use those decimals, it'd be better to use a box plot, maybe a stem plot, or a histogram, but definitely not dot plot. Okay. So what can we do? Well, you can round the data to the nearest whole number. 36, 33, 41, 36.2 is 36, that's 39, 39.5 is 40, that's 37, okay, and then the dot, dot, dot in between. Okay. And we have actually, how many pieces of data we have here? I think we have 30 pieces of data here. If you don't have this worksheet, then obviously hard to see what all the data is, because I'm not going to recopy down all the data right now. But I rounded all my data pieces first, and then I looked at my smallest. My smallest was about 32. Not about 32, it is 32. Okay, so I have 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. So I guess I don't need all that. I can stop there. Now notice, I'm not doing a traditional X and Y axis here. I'm starting off with whatever number I need and end up whatever number I need. I don't have a Y axis. What are we talking about here? We're talking about gas mileage. So what is this down here? Gas mileage in miles per gallon. Okay. And when you do this, you notice you have 132, and you can put either a dot there or an X. Some people like to do X's. Some people like to do dots. Well, we're just going to keep it with the name dot plots. I'm just going to use a dot. This one has 1 dot. This one has 2 dots. This one has 2 dots. This one has 4. This one has 1, 2, 3, 4, 5, 6. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you got a dot down here, 3 here, 4 here, and 3 here. Okay, so that's it for a dot plot. You're actually done right here. Okay, now if we had to explain a dot plot or describe it, let's take a moment, let's erase this. I want that dot plot to still be there so you can visualize it. But when we describe a dot plot, it is quantitative data. And when we describe quantitative data, we use something called GSOCs. Gaps, shape, outlier, center, spread. Now to help you get all this in, you're going to type all this into your graphing calculator. You're going to hit Stat into your graphing calculator, then Edit. We're going to edit whatever list you want, so we'll just go to list 1. Okay, and then you put all your data into list 1. Now when we put data into list 1, we're doing the decimal value, not the rounded value. Okay, and then after that you're going to hit Stat Calculate 1var stat, which is the first thing you see. And if you're using anything other than list 1, then you got to say second and then the list that you want. So I'm just going to put second 1 here, just to remind you that you do have to do second and the list that you want if it's not list 1. Now just get in the habit of just hitting second and the list you want. Okay, it just makes it easier. You can do it anyways with list 1, that's fine. Okay, then it gives you a bunch of stuff. Gives you mean, gives you standard deviation, gives you median, gives you Q1, Q3, so you can find IQR from that. Okay, a lot of good stuff. And so when you do that, you're going to find out that the mean is 37.2. The standard deviation, now there's 2 standard deviations. You do the one that says S, not sigma, is 2.398. Your 5-number summary is your min. Okay, I'm just running out of room here. Your min is 31.8. Your Q1, first quartile, 25th percentile, is 36.2. 36.95 is median. Q3, or your third quartile, is 39.3. And 41 is your max. Okay? Now, I'm actually going to then to find out if there are any outliers. Okay? So to find out if there are any outliers, you have to do second y equals, okay? And then you're going to do this choice that is the modified box plot, which is the fourth choice. And it looks something like this. Don't know exactly what it'll look, but they have dots to the side. Okie doke. And then when you do that, you can see if there are any outliers. And there are none. Okie doke. Now, so I'm going to describe in a moment. So let's go and look at stem plots. I'm going to use, now this is for B. There are three types of stem plots. There's your old standard stem plot, and split stem, and back-to-back. Okay, so let's look at B1, the old standard stem plot. The stem plot, I think they call them what, stem and leaf plot back in like middle school. On the left hand side is your stem, on the right hand side is your leaves. Our smallest number is 31 what we got there? 31.8. And our largest number is 41. Okay, so we say, okay, we got 31. Oh, we're going to need some more room. (31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Okay. And then we get 31.8. Well, that goes there. 32.7 goes there. 33.6, 34.2, 34.5. Notice putting in order. 35.1, 35.8, 36.2, 36.3, 0.3, 5, 7, 8, 9, 9. 0, 1, 2, 3, 9. 5, 0, 3, 5, 7, 9. 3, 5, 0, 0. Okay. You need to have a title. This is gas mileage. And I need a key. So pick a number over here, it doesn't matter. 35, 35/1 equals 35.1. 35.1 what? Miles per gallon. Okay. Now let's describe. Now we talked about that thing that was gaps, shape, outlier, center, spread. That's GSOX. Gaps. No gaps. Shape. Now you can look at the dot plot too, kind of draw a little curve around the data. If you were to turn this sideways from least to greatest, looking at from 31.8 to your left and 41 to your right, and you can also look at your dot plot, you'll see that the shape is skewed slightly left. Now, where is it skewed? It's skewed where it's more spread out. In other words, where that tail is longer. Okay, these tails. Where is that tail longer? Outliers. We double checked with our modified box plot. None. Center and spread. Now there's another lesson that I have on that's called mean versus median. And that lesson says if I use mean, I use standard deviation. If I use median, I use IQR, interquartile range. So which center, it doesn't matter, but you have to have the corresponding spread. And I also say in that little presentation that if it's a skewed data set, you probably should use median. So we have a median at, and we found out our median was 36.95 miles per gallon. And spread, if I use median, I use IQR. And there's a later lesson that I tell you that IQR is Q3 minus Q1. Q3 is 39.3. Q1 is 36.2. So 39.3 minus 36.2 is 3.1. And IQR, and again, this is a later lesson that goes with box plots, is the middle 50%. The middle 50% IQR is 3.1 miles per gallon, MPGs. Okay, don't say your middle 50% is from 36.2 to 39.3 because your interquartile range is an actual number. Okay, it doesn't go between two numbers, it's an actual number. And so there's our GSOCs for both the dot plot and this stem plot because we use the same data. Okay, now we're going to look at split stems. Suppose I gave you a data set that says, okay, our miles per gallon is, I'm just going to put them in order too, just make it real easy, 12, 15, 18, 19, 22, 23, 24, 25, 25, 26, 26, 26, 29, 30, 31, 33, 34, 42. Okay? Now, a split stem says this. I take these numbers here, and I have 1, 2, look, I'm looking at these numbers here, 3, 4, okay, 1, 2, 3, 4. Those are the numbers that I split, the first ones. When I split, they double, 1, 1, 2, 2, 3, 3, 4, 4. You're going to notice here in a moment, I don't need 2 4s. We're going to say this is gas mileage. Okay, gas mileage. And the first one, now we look at these numbers here. Okay, the first one, you look at those numbers, if it's 0 to 4, goes to the first one, and 5 through 9 goes to the second one. Okay, so 2 goes there, okay. 5 through 9, 5, 8, 9, that goes here. That's a split stem. So 1, that's 12, that's 15, that's 18, that's 19. Okay. Now I'm going to look at 22, 23, 24, 25, 25, 26, 26, 26, 29, 30, 1, 3, 4, whoop, whoop, 1, 3, 4, and then 42. So I leave that blank. Don't put a 0 there because that would stand for 30, which doesn't even go there anyways. But 42 goes here, and that's why I don't need that second 4. Okay, I need a key, and I will say, let's see, 2/3 is 23 miles per gallon. Okay, so now let's put this data into list 1. Now I haven't done this one I just made up, so I'm just going to do it real quick right now. Put in list 1, data into list 1. So you're going to hit stat, edit, okay, and I have 12/15, 18/19, 22/23, 24/25, 25/26, 26/26, 29/30, 31, 33, 34, and 42. Now I'm going to do stat, calculate, and then hit second one if you have it in list 1, and you get X bar is 25.55555, so 25.6. Standard deviation is 7.2. Min is 12. 5-number summary now. Q1 is 22. Median 25.5. Q3 30. Max 42. Now we're going to hit second, y equals, and we're going to hit the fourth choice, which is this. Modify box plot. Use your list, so second 1 if you need to. Zoom 9. And if you hit trace, go across, you notice say, hey, well, I don't have any outliers here. Okay. All right, so let's draw a little curve around here. So no outliers. So let's do GSOCs. Let's erase all this. Now it's good to write all those numbers down. Okay, can't hurt. Now, quantitative data, you always do GSOCs. Categorical data, you do not. Okay. G, gaps. Oh, there's a gap right here. Look at that 3 doesn't have this right here. Doesn't have anything. So there is a gap between 34 and 42. Well, 34 and 42 what? Miles per gallon. Shape. Now some of these shapes get kind of confusing and say, well, which way is it actually skewed here? Well, you got most of your data right here, and something over here is pulling it a little bit. It kind of counteracts. This looks pretty symmetrical. Approximately symmetrical. Outliers. None. Center. Well, that's symmetrical, so let's go ahead. So our center there's a mean at 25.6 miles per gallon, and spread is standard deviation with mean. The standard deviation is 7.2 miles per gallon. Okay, so we got that nice and good there, the split stems. Now we're going to do back-to-back stem plot. That's comparing two groups. So now we're looking at, okay, we have 4, we have B, and we're on number 3. And it has male doctors and female doctors. And male is 20, 25, 25, 27, 28, 31. I'm going to write them all down. And all the way up to 85 and 86. The female is 5, 7, 10, 14, 18, and 31, 33. When you do a back-to-back stem plot, now you can also do a back-to-back split stem if you want to. Now splitting stems, you can do that anytime. Okay? When we do a back-to-back, that's comparing two groups. Can't do more than two. Okay? So we look at these numbers again. Okay, all the way up to 8 there. And actually there's nothing here, so it's really 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. I'll put male on this side, females on this side. And this is in order. And males starts off with 20. So 20 is right here, 2, 0. And I have 25, and I go least to greatest inside out. 25, 27, 28, 31, 33, 34, 36, 37, 44. Oh, kind of going slanted here. See if I can. 7, 6, 4, 3, 1. 44, 50, 59, and no 6s or 7s, 85 and 86. Okay, now real quick I'm going to talk about this shape here. Now which way do you think that is skewed? Some people say skewed left, some people say skewed right. So which way is it? When you lay this on its side, you do it from least to greatest according to these. Okay? Least to greatest according to these. So that means these are on the left-hand side and these are on the right. So this is skewed right. Or skewed to the upper values. Okay? It's usually easier to tell on this side, but when you do it on this side, things get kind of backwards. Okay, we have 0, 5, 0, 7, 0, 4, 8, 9, 5, 9, 1, 3. And this, got to give it a title. And this is number of C-sections. Okay, what kind of shape is this? Well, that's pretty obvious. That's approximately symmetrical. we need a key. So let's pick 3/1 is 31 C-sections. Now let's describe or compare. Again, this is quantitative data, so we're going to use GSOCs. So what do we do? So we put this into list 1, put this maybe into list 2, and then you're going to, for the males, you're going to do stat, calculate, 1 stat, and then second 1 for list 1. And when you do that, you find out that the males, let's see, what do you want to use? We'll do mean and standard deviation here. How about that? So when we do that, mean is something. .3, and standard deviation is 20.6. Now if you did median and the other stuff, the 5-number summary, you would get 20 for your min, 27 for your Q1, 34 for the median, 50 for the Q3, and 86 for the max. Now let's go to second y equals, and let's do a modified box plot. And that shows that this guy and this guy are outliers. Okay. Now, let's repeat this process for females. So I'm putting that into list 2, and I'm going to do stat, calculate, 1 stat, second 2 for this one. And when I do that, I get, okay, X bar is 19.1, and standard deviation is 10.1. And if we were looking at the 5-number summary, maybe use the 5-number summary. Your min is 5, Q1 is 10, median is 18.5, Q3 is 29, and max is 33. Then we go ahead and do second y equals, and let's do that box plot again, and zoom 9, and then make sure we're using list 2. Okay, make sure you use list 2, and then zoom 9, and we find out that there are no outliers. Okay, so this has none. All right, let's take this away, and let's actually describe GSOCs. Gaps. Let's see, the male have a gap between 59 and 85 C-sections. Females have none. Okay, gaps, shape. The males are skewed right. Females approximately symmetrical. Outliers. The males have 2 at 85 and 86 C-sections. The females none. Okay? And then we have center and spread. I'm running out of room here. Let's see. Let's go ahead and get rid of some of this. Okay, center. You can either use mean or median, doesn't matter. We're going to use mean here, and we're going to compare the males have a larger mean, 41.3 C-sections, than the females. Remember, look, I'm using numbers here. Spread. Well, what kind of spread do we use with mean? We use standard deviation. Okay? So the males have a larger standard deviation which is 20.6 than the females, which is 10.1, and I gotta say what that is. That's a C-section. Okay, so that is it for stem plots and dot plots. Good luck. So this was quantitative data part 1 using dot plots and stem plots. When you have data, graph it as best you can, best visual representation, and when need, give the numerical summary like mean, median, standard deviation, IQR, so on and so forth. And you also want to describe when needed to. That's using GSOCs, gaps, shape, outlier, center, spread. You do not use GSOCs on bar graphs, only on quantitative graphs, not categorical. Okay? Good luck on dot plots and stem plots.